Now in this video here, we're going to combine our trig functions and our log and exponential functions as well. And we've seen this review chart already, so I'm not going to copy it again, but if you need it, it is in your book. And again, it just kind of provides that quick review here for your different log rules. So I've written this in our notes again already before, or at least the first three. So the last one is just basically that if two logs are the same, with the same base, then you can cancel the log part out and use m equals n. So that one's a little bit different, but the other ones we have already seen, or you should have seen in class and things like that. So if you need to, come back to your text and you can write this down or pause the video here, but these are common log rules that you should already be familiar with. So for the first equation, one thing I'm going to do, and a very common thing to do when solving for exponentials, particularly if you just have one e in the equation, there's not like multiple e's there, is you can take the natural log of both sides. Now, when you take the natural log of e, these are inverses, so they cancel each other out. We're using composition here, and you're left with just cosine x equals the natural log of 1. But the natural log of 1 is just 0. And you can see that just from knowing it, or if you plug it into your calculator, you get 0 there. Now, we do know our cosine values from 0 to 2 pi. So this is a great one that you can just use your chart for. We can find the exact values. And the ones that work there are pi over 2 and pi over 2. So just referring to our chart there, and again, because you have a restricted domain, you don't have to worry about all the extra ones. We typically have in that chart all the values from 0 to 2 pi for cosine. Now for the next one, I'm going to do the opposite idea. I'm going to raise each side using a base of e. And again, because that will cancel the e and the natural log out. So I'm going to take the e and I'm going to raise both sides. And what happens here is, again, e and natural log cancel. So you're left with just absolute value of sine x equals e to the 0, but sine x, or e to the 0 is just 1. So you have the absolute value of sine x equals 1. Now remember, absolute value is a distance. So two things could happen here. It could be that sine x equals 1, or it could be that sine x equals -1, right? Because absolute value of -1 is still 1. So with absolute values, remember you have two answers. You're going to set the right side equal to positive and negative. And now we can go ahead and solve. Again, it's between 0 and 2 pi, so our sign charts are pretty thorough there from 0 to 2 pi. And we can really just look up the values. So the two values that are going to work here are going to be x is equal to pi over 2 and 3 pi over 2. Now, one thing I am skipping over here is you do want to get used to checking solutions. So with taking the natural log of both sides, you don't usually have any issues there. Here, because we're raising two powers and stuff, you could create extraneous solutions. So you do want to get in the habit of checking your solutions here as well. So just check solutions. No extraneous here. So I'm going to skip that part because our videos are getting kind of long. But just a reminder that, whenever you're kind of using powers and things as well, it's a good idea to check your answers and make sure you have no extraneous solutions. So neither of these have any issues and they both work out fine. All right, let's do one more. And this one we're not going to be able to do exactly. It's going to be 2 to the tangent x equals, minus 8, 0. So for something like this, I would try to isolate the x as much as I can. So I'm going to add the 8 to both sides, and I have 2 tangent x is equal to 8. One of our strategies that we have used, or that you should have used in previous classes as well, and that we use with exponentials, is trying to get the same base. Now, we can get the same base here because 8 is the same thing as 2 cubed. And when that happens, basically you could sort of cancel out the bases. You actually take log base 2 of each side, but we're just going to cancel those out, and you're left with a new equation, which is just tan x equals 3. Now, again, this is one where I don't know tan x equals 3. That's not a common value that I am familiar with. So I'm going to go ahead and use my calculator for this one here. So I'm going to use my inverse function of 3. And when I do that, I do get a value. So I'm going to use 4 decimal places. Okay. And now here you just want to be careful. You want to remember that tangent is positive. And tangent is positive in the first quadrant and also in the third quadrant. So the value you get here is going to be from the first quadrant. So you have your first answer. And then for the third quadrant, the trick is just to add pi to it. And let's see, when we do that, we get about 4.3906. So that would be our second value here. And those are the 2 cases between 0 and 2 pi where tangent would be positive. Now, one last thing I want to note here, I'm going to stop sharing for a second, is that I try to bring it up. I want to bring up Desmos for you guys, is that Desmos is a really helpful tool. I've mentioned it, but I haven't actually really shown you a lot with it during these videos here. So let me share my screen. So the nice thing is when you're solving, and I'm going to do the last example we just had. Let's see if Desmos can do it actually. Okay. So what I have here is that last example we just did, but I've split it up. So I graphed the left side of the equation, the original equation, and then I graphed the right side of the equation. And where they meet, so you can see they meet right here. They also meet right here and so on, is where you have your solutions. Notice that these are the 2 answers that we got. Now we're only looking between 0 and 2 pi. So obviously there's more solutions because this is periodic, but graphing is such a wonderful tool. It's really so helpful here. And you can see I can quickly check my work in that last example by graphing each side and making sure my points are actually there. Looking at the example before, I'm actually going to go to the part where it was just at the end and we were trying to solve, right? We were trying to solve and say, well, where is sine x, right, equal to 1? So if you look at the example that we were just doing, we went through example B, we solved using our log and exponential rules, and then we got down to the fact that, okay, I need to know where sine x equals 1 and sine x equals -1. And again, you can see right here, I graph sine x, I graph 1, and where they intersect, that's where that solution is. So we got the value of pi over 2. And we also got the value of 3 pi over 2. So you can see those right there at those intersections. And again, we only needed between 0 and 2 pi. So this is just a really nice technique, I think, just to check your work. Going to example A here, again, just kind of looking at that last step, looking at cosine x. So I said each side equal to its own equation. And then there I was looking at the very end, well, where does cosine x equal 0? Right? So I graph those 2 equations, and if you click your points, you can see we got pi over 2 and we got 3 pi over 2. So graphing is really so helpful. I use it all the time to check my work. So, I mean, you've seen me, like sometimes I make mistakes, I go too quickly, I forget to check for extraneous solutions, whatever it is. By going to the graph at the end is really that nice visual to say, okay, were those the values that I actually got? Because your left side and your right side should be equal. And again, you can type in some of the ending results to see if you're correct, or you could type in those original equations. So looking at example A here, we were trying to solve e to the cosine x. And then we were trying to see, well, where does that equal 1? And again, 3 pi over 2 and pi over 2 were our answers. So it's just a really nice way to check your work. or to help you if you're getting stuck as well. You still have to watch for domain restrictions and things, but again, I really refer to graphs when I'm doing trig a lot. It's just a really great check, and it's a tool that I highly recommend.